Hey, this is Greg, and welcome back to the channel. This is part 6 of this never-ending saga of building a professional belt grinder by Phil Vandelay's plans. And this week I'm building the stand, shown here in Phil's plans. But I'm going to change it up again. In Phil's plans, it hinges by a pivot right here where the arrow is showing. And so in the horizontal position, it locks, but it hangs way out there, quite a lot of weight. There's the locking lever and pin. But in the vertical position, there is no lock. It just hangs there by its own weight. You have the tightener clamp, but there's no real way to get a locking lever in there. Because if you put a plate there to lock it there, then in the horizontal position, that's in the way. So looking around the internet, I found a bunch of other plans, and they tend to use this vertical straight-up post mounted on the back. And I think that's actually better. It's the way I'm going to go. So I started off making those brackets at the back. So when I was buying the steel, 3/4 and 1/2 inch steel, and the tubing for this project at a local steel supplier, as I was leaving I found this little scrap bin he had, lots of bits in there, and I grabbed a few little offcuts, and then I saw these things and I said, hey, can I have those too? And he said, yeah, sure, no problem, very nice. Thinking these might be perfect to make space metal to make the brackets out of that are going to be for the stand. I put a fly cutter on this to see how it would go, and it was very tough. I mean, I had to use coolant. Got a nice finish on it, but it's very tough material, so I'm guessing this is probably 4140, possibly even hardened to some degree. But I was able to fly cut it eventually. So now the holes are a little too big for my 1/2 inch bolts, unfortunately, but I do have some 1/2 inch bushings from another project with a 3/4 OD. So I'm going to see if I can put a 3/4 OD hole there and then base going forward on how difficult or easy that is. So this is just showing how I use a wiggler to scratch around the outside of hole to get a nice consistent sound to find the center. I do own one of those coaxial indicators, but I find they just take too long to set up. It's not worth it for a small job like this. So drilling out to 5/8 and reaming out to 3/4, and then I repeat it on the second part. Center finding, drilling, and reaming, and then testing the brass bushing. Fits fine. Okay, so I was able to enlarge those holes to 3/4 without too much difficulty, so my bushings fit in. So I guess I'm going to continue with the plan to use these two scraps. So I'm going to face mill both sides of both of them. So the next several operations without calming machine sounds are getting those pivot brackets attached to the rear of the attachment arm sleeve. So I cut them off to just a tad over 1 inch to allow for the stand legs to come, and then milled down their edges. So here's that rear attachment sleeve, and I'm finding its center so I can put in some clearance holes for some 5mm screws to come. These are what's going to attach those brackets onto the back of this. And I'm recording these positions in the DRO because I'm going to need them later. Now the cap head screws that are going to be used here have to get recessed into the back here flush to allow for the attachment arm to slide freely inside. So here's one of the brackets, finding its centers and edges so I can pop those holes into the same positions that are on the back of the attachment sleeve, of course, using the DRO. So I drill them out and then tap them to 5mm for my cap head screws. You're going to attach this part on there. And of course I repeat for the second one, and here they are attached, and everything's good. Then I temporarily assembled this to test the fit, and I found that the edges of those brackets were just a little too tall. I want them flush, so I put them back into the mill here and just did a real skim to flush them up with the tops of that sleeve, because I'm going to attach some more brackets on here, some strengthening brackets to come. So here I am finding the center again, drilling some holes while recording the positions again on a piece of paper for later. Also found the position of those 6mm holes in the sleeve, because they're going to be part of the bracket as well. It's going to be really sturdy with lots of screws in here. So tapping for 5mm in the top of the brackets, finding that 6mm position as well and recording it. This is just threading the other end bracket. So now I'm going to spend a while doing a purely cosmetic thing here to the main plate. Kind of got a bit of excess steel here that doesn't need to be here. I think it's going to look nice, a little notch cut in here. So I drilled those holes to give myself some room to get my portable bandsaw in there. And cut out the bulk of the material that way. And then moved it over to the mill so I could clean up the edges. And also chamfer the edges. And tilt it up to get the angles and chamfer them as well. Just getting everything all looking nice and chamfered and consistent. But purely cosmetic, as I said. So now I'm going to make some beefy support arms for those pivot brackets. You'll see how they're used in a moment. Start by cleaning up the surfaces of this big 1x2 mild steel. So let me describe what's going on with this piece that I just cleaned up. I'm going to use it to brace my pivot point here, my brackets on both sides. Obviously this is a big, beefy, far more beefy than it needs to be, piece of metal. I do need it a little extra thick because these holes stupidly don't line up. So I need to, in perfect hindsight, I would have made all this set of holes line up, and they don't. So I need some extra thickness just so I can get holes through it without, going out the sides. And then I want this piece long, if it's in frame there or not, I want this piece long here to make a handle and a place where I can clamp my part in a horizontal and vertical position. But it's not going to be this thick. I'm going to basically cut this down the center to give myself an inch block on each side, but in a little tricky design here. I'm going to come down like this on this piece and then go along halfway, and then for the other piece it'll use the end of this to go down halfway. Well, you'll see once I get it marked up. This chunk right here, the angle on there down to here, will be the bracket for the back side, and then flipping it over, this bracket here with a long handle on it, as long as I can get it, will be for the front side down. That'll follow this line. Yeah, it just sits there naturally, good and square. I'm going to cut down this line here, and I want to cut on that side of it. This is the good side. I put the extra piece that I cut off in here, same width. Of course, I could have used this thing here as well, but it's just easier to put a piece that's exactly the same width in there. And if I bring the bandsaw down, I am just barely on that side of the line, so that's good. And tighten her up as tight as I can go. And plug it in. After cutting this part down the center, I moved the pieces over to the mill so I could square them up as usual, get everything looking pretty. And there's one piece that has the angle on it for cosmetic purposes, so I used an angle block just to set that 30 degrees there and faced it off as well. Did exactly the same for the second part. Got it looking all pretty, including its 30-degree angle. And I just set them in position to see how they'd look. So I'm going to use transfer screws to find the bolt patterns for those brackets. I have some M6 and M5 transfer screws, but the M6s are too short because they're recessed. The part is recessed way down inside. So I'm going to make my own. I just cut off an M6 longer bolt here. I'm going to cut 6 flats on it so that it looks like this one. There's a tool that I can use to put it in and out. So I'm just going to cut 6 flats on it, the same dimensions as this, so that the tool fits on. I just cut those 6 sides off, turning it around in the collet chuck here. I had a little problem turning it around there for clearance. Got all 6 sides cut off, and then moved it over to the lathe so I could put a little sharp point on it there. First with the bit and then with the files. And yep, it's good and sharp and hard, so it should make a good mark. Okay, I've got my 3 transfer screws in there now, and you won't be able to see it from here, but I've made sure all 3 of them are level with each other. So hopefully they'll all make an impression when I put my piece down and give it a whack. So you can see my 3 punch marks there. A little sloppy, but I can figure out where their center lines are, and I've got my DRO positions from when I drilled the holes in the bracket. So as long as I can get the center things aligned with that, then I can get these guys put into the exact spots where the DRO had it before. And the punch marks are just really just sanity checks. So now with the part moved back over to the mill, I find the end and center positions so I can use my DRO that I recorded earlier for those 5.5mm and 6.5mm clearance holes for the 5 and 6mm bolts that I go through here to attach it. And then I assembled it just to make sure everything was good, and it is. Now I'm using a transfer punch here in the end holes to add additional bracing. This is part of Phil's design here. I had these holes in here, so I'm marking them with my transfer punch. Then I can take it apart again and move it back over to the mill so I can drill those holes and tap them in the ends of those arms or brackets. And of course I do that for both parts. These are 6mm threads that go in here. Second part. This little side project here was to sharpen all my bits. And I'm actually all finished them all. This is the last one I have to do. Just to show you, I highly recommend this Vevor little sharpener. Quite easy to use. There's a million YouTube videos on how to use this guy, so I'm not going to do it again. But it's quite tricky. Quite clever how this guy works. Just going to show this last one about how fast it is to grind a bit. This guy's got set to 135 for these cobalt drills. There's the sharpening, and there's the split point. And they're all done. I'm sure you can't see that on there, but it's a nice sharp bit. I've used a couple of them already, and they work out really nice. So here's the motor assembled to the frame on the bench, using one of these slots in the bench to put the motor shaft down. I just want to see my minimum amount of clearance I need here for the motor in its swing, and I'm going to say it's 7.5 really is going to do it. So 7.5 inches to the pivot point, 8.5 inches to the end of the tubing, and I'm giving myself just a little bit extra to allow for trimming. So as usual, after cutting off a leg just a little long, I can move it over to the mill, where I can surface all 4 sides to make them look pretty. And I also end mill just one end to square it up. The other end is going to get rounded over. So I do that for the second leg, and we're ready to go. So I decided I'm going to plug the end of these pipes, these uprights, the same as I did for the tube on the main part, down about 1 7/8 inches. So I've got to round over the edges of this, and I've got to take out the weld bead there. I bought this little small sander on a Harbor Freight special yesterday, so this will do short work of that weld, I hope. And just a flat disc to round over these corners. So I cut this off to twice length. I'm going to bang it in as far as I can in case I can't get it halfway. Then I'll just cut it off wherever that is and continue on with the second one. Well, I did get it in exactly halfway. Now I'll cut that off there. Then I have to round over as well. Do that in a bit. And then I measured my bolt in the shoulder and how much I have to countersink this for the shoulder. I have to go down here just a hair over 1 inch to give myself enough shoulder depth for that 1/2 inch bolt that's going to go in there, and then the rest of it's going to be tapped. Just want to point out the 1/2-13 tap has a center punch, whereas the smaller tap that I just was using, the 6mm, has a center point. And a tap follower is double-ended. It's got a, an indent for the points and a point for the indents. But it seems that every single time I use this guy, I've got to flip them around. I should buy a second one of these or make a second one. Doesn't take long, but it's just kind of tedious to have to do this all the time. So flip it around so the point's going down. Spring back in. Allen key back in. And now I've got a point tap follower. So here it is all assembled on the bench temporarily. Just wanted to see my dimensions were working out, and they are. I have to round these over, of course, so I can actually pivot these by horizontal and vertical. So far it's just in the vertical position. This bracket here was extended intentionally to put a handle. I'm going to put a brass handle on this to facilitate changing positions. And then here it is in the vertical. And for a base, I could just weld it on this 1/4 inch plate right here. It would look fine, but it's kind of an expensive proposition. Instead, I'm going to make some tubular steel legs and put them off in little diagonals here for better stability. But that's it. And then this handle here will help you, turn it horizontal, vertical. And it'll also have the pin in here. Well, you'll see. There's going to be a plate welded on here that the pin's going to go through to hold it in the horizontal, vertical position. That's it. But first of all, I'm going to take it apart, hit these brackets off. These bronze bushings here extend about 1/8 of an inch, and I have 1/8 of an inch of extra distance here available. So I'm going to recess those guys in. I'm going to mill out little divots for those bronze bushings. I think it'll look nicer. It'll space these legs just that little bit, 1/4 inch further apart. I'm just going to do something purely cosmetic here with the brackets. I glued this up and just described on here. I'm going to make a slot in each of the brackets just to look pretty. I happen to have a 5/8 drill, so I'm going to make it 5/8 wide. So edge fine. I've got this lined up with the edge of the vise here so I can get the second one the same without moving too much stuff around. So I'll find the center of this first. So I can cut the slot in the center. So now I brought in my 5/8 bit here. Let's see how it performs. This mill is just barely deep enough to reach through to the bottom. Gotta use it all. Okay, so I'm just going to repeat the same steps to cut the slot in this other bracket. I have it even with the end of the jaw here as the last one is. I don't have to do anything else. I got my Y already set. Got my X set at 1 inch there for the first hole. I think I can chamfer this whole circumference in one pass here. Okay, I have this mounted in here flush. I need to counter bore each of these. These are for 5 millimeters, this is for 6 millimeters. Okay, I need to round over these leg ends with a 2-inch diameter, 1-inch radius. I actually used a platen wheel, which is exactly 2 inches in the hole there. It's also 1/2 inch to scribe a mark. Then I use my bandsaw to cut down the corners, and I grind it around off a little bit to save myself some time on the mill. So now I can rotate this around and do the perimeter there, the circumference. Got that centered on the hole so that my curve will be centered. And that's just a matter of eating down. I'm going to have to do this in 4 parts. I'll do this top part, then I'll flip it over, do that part, and then I'll have to put the parts together the other way and do the centers. Okay, I couldn't put the 2 pieces together in the opposite direction because the threads are only on one side, so instead I've got a long bolt down through the bottom of the vise here, and that gives me a pretty solid pivot here. I've got this centered on the bolt again, so I can get this over here and get it centered and start cutting away again. Jesus. Fuck. Just my repair to that gash I did earlier. Just filled it with some weld metal. I'm going to face it off again. Never happened. So now I'm going to weld in a cross brace in between the 2 stand legs for strengthening. So here I'm just going to cut it off on the bandsaw to begin with, a little long. And as usual, facing all 4 sides, then cleaning up the ends to an exact length that'll just fit between those legs. And then welding it into position. Now here I am tacking it up. I forgot to turn my argon on, so I got those fireworks. Very nice. Went over and turned on the argon and came back and finished up my tack welding. Fixed that first one, and then the other side. Here I am making a cardboard template that'll eventually become the positioner plate made out of steel. It's going to go here to hold the locking pin in place. And I spent a little while figuring out how I can get that piece of steel cut out of the same base plate that is going to form the stand base. So here I'm just adjusting the position of the legs a little further higher to fit that piece of cardboard in there. No, wouldn't fit, so I trimmed it a bit, and now it'll work. So now that I've got it laid out on this piece of steel, next I clamped the whole assembly down on top of those square Sharpie marks to make sure everything's going to work fine, and it did. And I cut out my positioning plate, and then I tacked it into place with a little spacer in there between the handle, and then moved it down to the other position, the horizontal position, and tacked in the bottom, again with the spacer in place. As I point out here, that spacer turned out to not be quite wide enough. I ended up trimming down the handle just a little bit to clear for the thickness of the paint later on. It moves well. Now with the handle removed here, I'm preparing it for the positioning plunger. So of course drilling it out to the proper size, figuring its depth there, putting an indent for the shaft of it, and to accommodate the nut so I can get it deep enough, and then tapping it. And it fits well, and it's got enough depth in the bottom. So now I've put the handle into a 4-jaw chuck here and got it spinning fairly true so that I can put a taper on the end of it here so the square will form a cylinder of 1-inch diameter that's going to mate up with a brass handle I'm going to make here in a moment. And then drilling and tapping the end of the handle here for an 8mm threaded rod that's going to hold the handle in place. And then here's making the handle itself out of a 1-inch piece of brass. You've seen me do this several times, a very simple procedure. Just getting it cleaned up. And then I put these nice little decorative marks at a 1/4 inch apart that I did for the tensioning lever as well, so they match. And then cut it off. And use some soft jaws to hold it while I drill and tap it for the 8mm. It's going to hold it to the handle. And there it is, not too bad. So on the home stretch of this part 6, I just need to weld up the rest of the stand to the base. Whenever I'm starting a welding project, I like to sharpen up a whole box of tungstens here, so I know I'm going to go through some of them. I'm not the most expert welder. So I've got this double-decker polisher grinder situation here just to save some space. Turn on my grinder. It's going to be loud, of course, when I turn this on. I've got a mask for my tungsten dust. I think I'm going to turn the fan on behind me as well, so it's going to get very loud because it's about 90 degrees in the garage here right now. Be right back. Okay, fan's on, grinder's on. First thing I like to do is just start with a little light dressing. These guys are already pretty good. Torque wheel and the fine wheel. And then I just like to put my tungsten into a electric drill and sharpen them out like so. Start on this grinder to get a nice point just like that. That was a pretty clean one already. Here's one a little worse shape. I'll start on the coarse wheel. I just eyeball the angle. As long as I get them consistent so the welds are all the same. And there's 2. So there we go, the whole box sharpened in about 5 minutes. And 1 finger burn. I took one out of the short ones out when it was still hot. Gave myself a pretty nice burn. But I'll survive. And I also separated the longer ones and the short ones. Stubby ones. Okay, time to finish up these welds around the base and the bracket here. I'm a spectacularly mediocre welder, so you're not going to learn anything here. The only thing I know is I need to wear long sleeves, so you get a sunburn pretty darn quickly. Obviously a proper helmet and gloves. I want to avoid warping, so I'm going to do it in sections, a little bit here, a little bit there. I'm going to keep it clamped down as much as practical, again to try to avoid warping. And that's about it. I'm just going to go around and do my thing. It's going to be hot as hell in here because I can't run the fan while I'm welding because the fan would blow away the argon, and that's how you get burns pretty darn quickly, as you saw in a little demo yesterday. So I got the TIG set at 125, 1/4 inch base metal here, 1/4 inch wall thickness here. Should be about right. Get suited up here and lay down my first little pass. And then I'll probably cut to the end because, again, you're not going to learn anything from my mediocre welding. Got a beautiful stack of dimes, or maybe not dimes but something else, but they're a stack of something. Anyway, that's my welding, and I'm just going to continue around the whole perimeter of both the legs here. Maybe bring you back for as I weld up the little bracket here. So I've cleaned things up pretty well. Welds look pretty good. Don't have to be a good welder, you just have to be a good grinder, they say. So here was a pretty big side project during this build and why it took so long. It's been 90 degrees and up in Florida for the last 2, 3, 4 weeks now with no end in sight, just really, really hot. And this garage, when it's 90 degrees outside, is 120 degrees inside. So I finally got around to insulating my garage door, put a strip down on the bottom as well. Got everything all tuned up. The sealer there. Also sealed the outsides. So everything all is pretty leak proof. And then the big deal is I installed a mini split AC. And now that I've done it, I wish I'd done it years and years ago when I bought the place. It's just been so nice in here now. I've got it set at 75 and it keeps 75. Big job, of course, to set it up, but there's the outdoor unit all plumbed in, all looking neat. And so now I can actually have some nice comfort in my garage, which is so much nicer. So I'm finally able to do a workout here at my own time, at my own pace, without having to worry about the heat, and especially about not worrying about the mosquitoes as well. So as you can see, I've got it reassembled here, and just with 3 shims here in between the main plate and the base, I find that makes it perfectly square to the base, which is where I want it. And so now I'm going to put some Prussian blue on my spring plunger here and make a mark for drilling in the flange here. Looks like that's doing it right there. Now I can take it off again. Let's see what I've got here. I'll gotta take my shim out first. Oh yeah, that's perfect. I can see the center of that just fine. Then off camera I hand drilled that hole, reamed it out, and repeated it for the horizontal position. So this arm is just barely rubbing on the flange on the base. It's just the thickness of the paint, really. I'm just going to skim off just the tiniest bit off the surface of this and make it look pretty at the same time with this fly cutter. So here it is all put together again on the bench. The base is obviously the new addition here. Everything else was made in previous videos. So to show you the base in action, there it is in the vertical position. Drops into the horizontal just like that, and it's very solid, and back to the vertical. Works great. And I've got just enough clearance here for the motor. Just barely clears there by about 1/8 of an inch, honestly. It's very close, but it fits perfectly, and that's all you need. And it's very sturdy this way. When I finally have it on the real bench, I'll probably drill 4 holes in here and bolt it down. But it's very sturdy the way it is, and it's very nicely balanced. I kind of like the way it balances. It's easy to push in either position. So hey, it's a wrap. So now I have the bulk of the grinder built, except for the platen and table parts. It currently ends with this 1.5 inch rod. If you look at what Phil calls his front view, I think it is the back, but he calls it the front, there's this L-shaped bracket that firmly attaches to the end of that 1.5 inch rod. It's got a split clamp onto this 1 inch rod so the table can be adjusted vertically. And the top of that 1 inch rod is held by this bracket, which in turn holds another 1 inch rod horizontally. And then the split clamp allows the table to be adjusted horizontally and ultimately holds the table in place. So all of that is what I hope to get accomplished in the next part 7 of this series. And time permitting, I'll also make this simple platen and the brackets that hold the platen. There's lots of parts, and we'll see how far we get. I hope you'll subscribe and watch the next part of the series. And as always, thanks for watching. Bye for now.